Hello everyone. Today we're going to talk about another flavor of XSS called DOM XSS. Now, cross-site scripting is a well-known vulnerability that allows attackers to inject malicious script into web pages. Now, one of the most sneaky forms of this attack is a DOM-based XSS, where a malicious code is executed directly in the browser, manipulating the DOM object model. Now, often without the server even knowing, because this is just kind of like a client-side attack. Now, let's dive deep into the basics of DOM XSS. What's a DOM? Obviously, DOM is abbreviation for document object model. It's just, you can think of it as a blueprint or a map for a web page, where everything appears on a website, like messages or form elements, or maybe a button or links or something that that is part of it. So JavaScript uses DOM to dynamically modify the structure of these elements, like the images, the text, and the content of the web page while it is being viewed. That's why it's called dynamic. And now this allows the page to be interactive, updating the content and response and user actions. Now, I feel like this is a good introduction. On my blog post, I have gone in detail on the DOM structure and how the JavaScript updates the DOM. But I feel like for this video, we need to focus on the vulnerability. Anybody can actually go. I'll leave a link on my description for the video of this blog post, so you can go through it if you would like. But I believe this is something you could read through anywhere on the internet. But there's two concepts that we need to actually clear out. I'll take about 1 minute or 2 minutes to express those two concepts. Now, the two key concepts is there is a thing called source and the sink. Now, what is a source? It used to confuse me a lot, but after I understood this major 2 points, it's become a lot easier for me to actually test DOM XSS. So what is the source? The source is just a location where the untrusted data uh, enters the JavaScript code. Now, when it comes to DOM XSS, there's no input validation. Like just like the other flavors, no input validation. The JavaScript enters and into the DOM gets executed. Now, if it could be user input, how is this getting in, or the entry point? It could be user input, like a parameter, URL parameter, or it could be kind of like a uh, form where it does have input and user types in their input could be username, password, or maybe search parameter, like there's a search field and user search through it. So this is just going to be a typical uh, XSS, the same kind of way you see an input entry point. That's where the source is called. And examples, your parameter, form inputs, and web storage. Now the second one is kind of like, I feel like the newest one, a sink. A sink is just a place where your JavaScript code, where untrusted data is written into the DOM. So your JavaScript will have two sections if it has DOM XSS. An entry point, also called the source, and the sink. The sink is where the the untrusted data is executed and manipulating your DOM. Now, if the untrusted data is executed, uh, written to the sink without proper sanitization, it can execute. It means it can execute anything, which is a malicious JavaScript. When I say anything, it means obviously this functions can be used. This examples of sinks, innerHTML, document.write, eval, jQuery.html, they can be used for a proper way, non-malicious way. But a malicious user can actually use this same functions to actually execute malicious JavaScript. So now I'm gonna go ahead straight to our demo. Now on our demo, I actually created on the PinewoodStore, I created a page called Giftcard.html, and it actually uses the sink jQuery.html. But I'm gonna demo that as well during our conversation. So let's go back. First thing, let me check to see if my application is running up and running. So I'm gonna go ahead. All right, the first thing is we need to test the application, right? I'm gonna go to the gift cards. I'm gonna put some random data in here. I already have actually populated, so uh, Now I'm gonna go ahead and send this. And as you can see here, it updates the DOM element here that is showing up. Obviously, this is gonna fade out and also it's showing up here. So there is a parameter called message and it's using that to update the DOM element. And if it does that, we know it updates the value of this variable directly using the value of whatever we entered on this field. So the value of this input field is considered what's called a source. And whatever is the function being used to update the element here, it is actually going to be the sync. And we're going to see that in a minute. So if I were to inspect this, I actually put it on a detail in here. So if I were to go up here, this is a script tag. So basically what it does, this JavaScript, what it does is actually it has a function declared, and the function is it gets the value of whatever you passed it. Let's say if you pass it a variable, a parameter name, it retrieves the value of that parameter name from the URL. So that's the definition. And whenever the send gift button is actually pushed, what it does is actually it sends a message and encodes it and sends it to the URL. It's basically that's what you're seeing here. We know that location.href, we know that location.pass name, and send the message. And that's why you're seeing the message here, which is being tapped here. Now, talking about the source and the sync. So in this here, it defines a variable, JavaScript variable, constant variable called message param, and it uses that function and whatever is being passed. Basically what it is saying is, if you notice here, this function is not doing any input validation. It's just using regex to extract the value of name from the parameter. And that is being used directly here and being used on another function, jQuery function.html. So we have all the requirements filled to have a DOM XSS. We have a source and we have a sync. And the sync here is .html, which is a method for jQuery. So now that we understand how the vulnerability works, let's try to see, because the rest of the process would be your usual process for others, right? You're going to use your normal alert JavaScript and try to see if it does execute the JavaScript. And if it does, and we can try to make it malicious and try to send the cookie to a remote site. So, all right, let me go ahead and fill this information again. And well, we already tested this, so let me go ahead. All right, let's send this, and if it is vulnerable, we get that. If we execute this JavaScript, we get the alert. So, and which it did. So now that we know it is vulnerable and we know how to exploit it, the next step is going to be how do we, obviously, a couple of things I want to point out. The reason why this worked, and I've pointed out multiple times when we did the previous XSS videos for stored XSS and reflected XSS. Now, all modern applications have a feature called HTTP only. Now, on this application is based off JWT authentication. Basically, when you log in, so what we're gonna do is, first off, let me log in before we try to steal the cookie. Because if you don't log in, you're not gonna have a cookie, right? It's because right now, if I were to actually inspect it and go to application and go to cookie, there's nothing because I'm not logged in. All right, I'm logged in now. There's a cookie generated. Now, if I were to duplicate this and go back to that gift card page. All right, So now, because we're going to simulate what happens, right? Uh, a, a victim is going to be logged in to the site and is going to access a page that has uh, the vulnerability, which in this case the DOM XSS. He will receive a link through some phishing activity, maybe kind of like an email or something like that. And he'll click on that, and basically at that point, what happens is he will be able to log in. I mean, his cookie would be stolen and sent over to a remote attacker controlled server. So which is what we're going to demonstrate right now. So, right. The first thing is let's try to see a couple of things. So if you notice here, if I inspect this, let me go back here. If I inspect this, this is the cookie, and it just basically carries the JWT token. Now, if you notice here, the HTTP only is not checked. Now, most modern applications will have that checked, and that's the reason why, even if you find some vulnerability that allows cross-site scripting, and if the JavaScript executes on the users on the victim's browser, JavaScript is not going to be able to read the value of the cookie. So in that case, it's not going to be successful. But just to demo that the full exploit, I'm turning this off, and also I just want to show you what we're gonna do. We're gonna do it. We're gonna demo using when HTTP only is off, which is off right now, because it would be check mark if it's not. And the next time is I'm gonna turn it on, and we can try to read it, and you'll see it is actually not gonna be able to read it. All right. So that being said, let's go ahead and first let's read it. So I'm gonna use the same script. Alert. This time, this alert is going to show document.cookie. John Doe 18. So let me go ahead and send it. As you can see, this is a JWT token. So it could read it because the HTTP only is turned off. Now, before we execute this and steal the cookie and send it to a remote site, I already have a webhook.site. We're going to use the Fetch API to do that. I've done it on the previous videos. At this point, honestly, if you watch the previous videos, it's just going to be a repeat of everything that we did. So, with that being said, let me show you what would happen in the typical case which is going to be on modern applications. This is where the snippet is. This is where the post is going to happen. The login post is going to supply the username and password. This is where I create a JWT token. If you see here, like once the login is successful, the user supplies the username and password. It gets passed from this form to the backend and the backend validates it. What it is going to do, obviously, since this is a JWT token, authentication is going to generate the JWT token, and that's why you see this. Once the token is generated, it would write it to a cookie. This is basically what it is doing. Is writing it to a cookie with a cookie named JWT token, which I demonstrated earlier on. But if you notice, JWT cookie, it set HTTP only. I set it to false for this demo. But if I were to set it to true, this attack would not be possible. So, because I actually demonstrated it with the session ID, it was a different kind of authentication previously. I just want to show you what the same thing, well, obviously in a different configuration, because the previous labs, they don't use JWT authentication for anyway. The ones I demoed for cross-site scripting stored and reflected, but I want to show it for JWT authentication as well. So I turned it on. It said HTTP only, set to true. I'm gonna go ahead and save it. Obviously, I need to start the application. So first off, before I do anything, I'm logged in here because it creates a problem most of the time if you don't. Yeah, so all right, so let me go back, and I made the change. I changed it to true. I don't think I refreshed it because we're gonna use the same. Oh, I refreshed it, but yeah, I can type it again, but I'll show you it's not gonna work either way. And I can it would also come up here on this console log for the application, so we can take a look at it. All right, I set it to true, and I'm gonna stop the application and restart the application. So let's wait for it to come back on, maybe 1 or 2 seconds. Then I'll refresh this page, and it should be good. Because it's still executing that. So let's go ahead and, as a matter of fact, let me just go ahead and close this and duplicate this. Instead of this, let's go to the home page. I'm gonna go to the gift cards page. Now if I refresh it, nothing. So we start fresh. First thing, there's no cookie, so let's make sure there's a cookie so we can demonstrate that. There's a cookie generated. Now I'm gonna go ahead and try to see if I can exploit the vulnerability now. And this is gonna be script alerts, and the alert should show document.cookie. And your name, in this case, John Doe. All right, let me go ahead and submit it. Now we're gonna get the pop-up, but it's not gonna be able to read it. So that's what you can see. Yeah, you see, there's no JWT token, but I do have a token. It's just HTTP only is turned on. This, you see the check mark. So that's why usually if an attacker even has a vulnerable point in some part of the application, most of the time, stealing a cookie nowadays is not going to be a simple task unless, like, for some odd reason, I don't see no reason why, but for some odd reason, the team turned off this HTTP only. But most modern applications and production, they would have that feature. So what you can do when it comes to cross-site scripting, you can probably redirect to a phishing site and do some kind of credential harvesting, and that's kind of like the key. There's also the key logger, which I also demonstrated on my other video. But the problem with that is to log a key, to get, like, the whole purpose of a key logging is, let's say you go to a website, you type in your username and password, that would be logged in. So that way, each key that you press will be logged in and sent over to a attacker controlled server, which I demonstrated on stored XSS. Now, for that to be effective, the JavaScript has to be executed multiple times, right? Each time the page refreshes, it has to be executed multiple times. So for that to be possible, you would need some kind of way for JavaScript to execute. But this is more of a case where it only gets executed, for this particular case anyway, when the attacker clicks on a link, right? So there are certain situations that would work for certain cases. So there's something that you need to consider, honestly, if you want to show a full proof of concept for any bug bounty program. But most of the time, if you can show something with alert, you don't even have to get to how you can steal cookies or anything like that. You get the full price, assuming that's what you want it for. And I'm saying this is all for educational purposes, my purpose in life. So that being said, so let's go ahead and demonstrate. I'm gonna go ahead and turn it back on, so we could be able to steal the cookie. So let's go ahead. and save it. It's because I stopped it in the middle. That's why I'm getting this error message in Eclipse. It's an Eclipse issue, which I need to update. But in any case, let me go ahead and log out here. The application is stopped. That's why it is actually acting this way. As you can see, it's not running. So let me clear it. Let's go ahead and start it again. Try to hit the home page. Alright, so let's try to log in. First thing, let's make sure 1, 2. Alright, user is logged in. As you can see, the HTTP only is not, there's no check mark, so we can execute the same script and get the Alright, name John Doe. Alright, let's send it. This is XSS is working, so let's try to see if I can steal the cookie now. This time around. As you can see, it can read the cookie now. So the next step is obviously we need to devise a way for this to send this cookie over to our attacker controlled server. Alright, so now let's go ahead and try to see if we can steal the cookie and send it to remote server. In this case, I'm going to be using the webhook site. So I do have this domain here with HTTPS. So first, let's test it. I believe we tested it already, but we'll still test it again. And it's reading the cookie. So the next thing is obviously we need to use the Fetch API and send it to an attacker controlled server. In our case, which is going to be the webhook.site, right? But if you have a collaborator, you can use collaborator domain or generated endpoint. So, and this here. Instead of alert, fetch. I like to do this way so I don't miss anything. Then inside of it, it's just gonna be first thing, it's a URL. Let's copy this. Come back here. And comma. This is gonna contain a JSON key value pairs. So first one would be method post. The second one is mode. it's just basically stating what the fetch API is going to do, what kind of method it's going to do. You need to supply those. So, and the mode is basically talking about should it do no course configuration or course, and in our case we need to do course, no course. So we don't need that. And finally, obviously, this request needs to carry the cookie over to the remote server as a body of the request. So you can do body document.cookie. Yeah, as you can see, we received a new request and it does have the JWT token. So what we're going to do now is actually we're going to use this and try to see if we can get access to this person's account. Now I have this user's account logged in as Jack B. So what I'm going to do, I'm going to open up a new browser. I'm going to use this stolen JWT token, and I'm going to show you I can actually log in. So, and after that, we just conclude by saying, by talking about how we can avoid DOM XSS, and that's it. All right. So now that we've confirmed the vulnerability exists, we tested with alert JavaScript. Then we send the request. We send it as a fetch API request to a remote site, just like an attacker would do. Now, the next step for an attacker is he has confirmed the vulnerability exists. He has created the payload. Now, by sending the last request and getting the request on the webhook site, he has created the payload, right? All he has to do now is just send this, because the way that this HTML code works, or the JavaScript works, is it would actually, whatever you type in his message inbox, it would actually be converted to a URL encoded and sent over as a value for the parameter message. And that's the reason why the message is actually a source when we talked about it. So the next thing that attacker would do is he had the URL, he's just going to copy it over and send it to the victim. He wants the victim to click on it. So he's going to go ahead and let's say, let me go to another email so I can send it. So the demo would be complete one. Alright, so I have this one. And I'm going to send it to the victim. New iPhone, whatever. Send. So basically, realistic attack, that's what it looks like. The attacker is logged in, he has a session cookie that is active, he's working on the site, and he's on the site, and he probably gets an email, right? And at some point he decides, okay, there's an iPhone, new iPhone, and he sees that. And as you can see, I just want to show you this because it doesn't have any request right now. He sees that, and what ends up happening is he's going to think, oh, okay, this is just going to be something, let me check it out or something. Obviously the phishing attempt is going to be convincing for whatever he likes or wants to buy or something. That's why XSS might not be this kind of attack might not be effective, because it really is enough to click. The victim is convinced enough to click on this. So, right, and I'm gonna go ahead and click on. He clicked on it. It redirects him to this page. He might not think a whole lot of it, but what happened is because he clicked on that, his cookie got stolen and sent over to attacker control site. In our case, we're using the webhook site, and as you can see here, there is a new entry that came in. It actually stole the JWT token. So All right, so now we have the JWT token that has been stolen using DOM XSS. Let's try to see if we can log in. Now, just to demonstrate to you, this is actually using by exploiting the DOM XSS and using that JWT token. I'm gonna open up. I'm gonna use a different browser that doesn't have any cookies, so it's actually believable that this is not a cached cookie or something. So if we go to storage, you have a cookie about. So first off, let's go to the site. So this is a site, and if I were to go up here, it doesn't have any cookie. But I have the stolen cookie. So let's try to log in by using that. The way you do it is you hit the plus icon here, and you're gonna come back here. You're gonna add the cookie. Basically, you write the cookie. All right, and the value of the JWT token is gonna be this one. All right, so now that you have a valid token that is actually being written to the cookie, you can try to log in or try to access an internal page. Then it would allow you to access the internal page allowed for this user. Now this user, where the victim user, is the one that is logged in here, and let me kind of Jack B. So let's go ahead and try to access. So try to access the internal page. If I'm trying to go to employees, I can see internal page. So, all right. So that actually concludes our discussion on DOM XSS as far as the demo on how to it gets exploited. Let's go over some few factors. So how to protect it, obviously use the right methods or functions so they don't get exploited. When it comes to DOM XSS, it depends on your HTML code. If you're using any of this methods, make sure you're using the methods. The most widely used one that actually allows DOM XSS exploitation is the innerHTML. So instead of using that, you can use the text context. It does the same thing. And sanitize is just for any XSS or most of the vulnerabilities is actually sanitizing will save you a lot of protect you from a lot of vulnerabilities. So sanitize input, but you can use DOM purify, and implement content security policies is another way, and validate and sanitize your parameters, and use automated scanning. Now automated scanning is a hit and miss, honestly, but yeah, I just put it up here so you might try your luck with it, but sometimes it might be a little bit advanced, and either Burp Suite or Zap, they might miss it. So in my opinion, you shouldn't rely too much on the automated scans.